Hello everyone, in today's video we are discussing about the language hierarchy. So in language hierarchy we have regular language, context free language and decodable and semi-decodable language. So here this is a diagram how we represent a language hierarchy, that is regular language first, and next we have context free language, next we have decodable language, and next we have semi-decodable language. And regular language will accept only the finite state machine. Context free language will only accept the push down automata. Decodable language will decide by Turing machine, which always halts, and semi decodable language will accept some Turing machine which halts all the strings. Okay, for now you remember this only, and next when we solve the problem you will get to know. So now I will explain about the regular language. So regular language, it is a finite state machine, and this language is said to be regular language if and only if some finite state machine recognize it. And what are languages which are not regular? Languages which are not recognized by FSM, languages which require memory. Memory of a FSM is very limited. Okay, and next, so it recognize FSM means it should accept A and B input given, then all the states should accept those. So here we have got that 1, 2, 3 are the state, A, B are input. So here the arrow mark is given at the start, that is a start state. So we will represent in this form, and some number of expecting state and final state are double circle. So here 1, 2 are the final state or accepting state. Okay. So for this regular language, how we are defining? So states are 1, 2, 3. We can name it as anything. Input are A, B, that is sigma. Whenever we have got A, B or A101, those will be sigma denoted by. From FSM we can say that whenever input A is given, it will stay in state 1. As long as it reads A, it will stay in 1 state. And next, when it is getting state 1 is getting input B, where it is moving to state 2. That is what we have written here. State 1 get input B, it moves to state 2. As long as it reads B, it stays in state 2 itself. Okay, it is staying in 2 itself. And when state 2 get a, it goes to state 3, non-accepting state. So here non-accepting state is nothing but it is not a final state, and double circle are there for state 1 and state 2. So these are accepting and final state, and here these strings will be possible and rejects the BA because see it is starting from A and it can end with only B. Okay, so here it is non-accepting. After final state, whatever we are sending, it is a non-accepting. I hope you understood. So next we will see the context free language. So these are the simple languages that are not regular, and languages of balanced parenthesis. For example, these are special character and we are not able to find strings for this. Even though we are finding strings, so it is difficult to read. So see, is it not difficult? We can, for AB01 we can read easily, but these type we can't read easily. So that type of problems will be solved by context free language. For example, A raised to n, B raised to n, that is we have that all n is greater than or equals to 0. So it should follow A and B with epsilon. All because it is a 0, we are taking this epsilon. So this will be taken only by examples of push down automata. Okay, so when we are solving problem, you will get to know about this. So next we will discuss about the semi-decodable and decodable language. So now we are discussing about semi-decodable language and decodable. So these are solvable problem and semi-decodable are non-solvable. So when FSM accepts regular language, falls in decodable language, and when CFG, that is context free languages, are solving the problems, it will form in semi-decodable language. And decodable language, that is L1 and L2 are two regular languages which are closed under union concatenation clean closure. Here context free language is also under concatenation union, and whether these languages a given context free language or not, and if no algorithm solves problems, it is called as unsolvable or a semi-decidable language. Thank you.